Hello there. I'm going to just give you a quick update on the programmable timer counter project. It's starting to actually morph into a coherent project now. I've got all the pieces laid out on the board with proper spacing where I should be able to get everything wired up, and figured out what type of processor I'm going to use in the final layout. And I'm gonna stick with an 8051 or 8052 because I'm gonna need a little bit of internal RAM to handle some variables, and also the 2 or 3 16-bit counters it brings along with it will be helpful in the capabilities of the final project. Overview of what I got on the board. 8051 or 52 is going to be here. The program memory, an EEPROM, address selector, address latch, and two 374s for two 8-bit output ports, because the 8051 is not going to have enough output ports to control the switching matrix on its own, so two additional 8-bit output ports generated by the 374s. The three 16-bit counters in the 8253 or 8254 switching matrix, comprising of three 8-to-1 data selectors, some glue logic here, some OR gates and NOT gates, two dual D flip-flops here for the PLL functionality, each of them to drive each of the two individual voltage controlled oscillators. The gate source selector, the 8-unit line driver, which will serve as the output driver for the outputs of the counter, and buffer for the inputs. 3 crystals, 1 GHz prescaler, and I've already got everything soldered roughly in place and got all the power lines bridged in place and everything, so all I got to do now is work on the actual data and control lines, which is going to be wires running across the top of the board like in my other project builds. And since everybody's one or two people ask lay out a schematic or whatever, I took the time to draw this up for you, give you an idea of the switching matrix I have in mind. You have the 3 crystal oscillators, the prescaler output and raw input, that each of those will be selectable from an 8-to-1 data selector that's on the beginning of each counting chain. Each counting chain comprises of a 8-to-1 data selector, the 16-bit counter in the 8254, and the 16-bit counter in the chip itself, where we run in series, and each of these counting chains will have the same option for input as the first one, so each of these will be able to pull off the 3 crystal oscillators, 2 inputs, and each of the counting chains will be able to pull off the output of the other 2 counting chains. So the possible input for each counting chain: 3 oscillators, prescaler output, raw input, or the output of the other two counting chains, and the lower two counting chains will have an optional input from the VCO in question. The first VCO goes to the counting chain 1, and second VCO goes into counting chain 2, and the PLL for those two counting chains will pull off the subsequent counting chain and the reference. So the PLL for VCO1 will pull off the reference and pull off the counting chain, the next counting chain, and produce a PLL phase lock loop. And the second one will also pull off of the reference, and the second counting chain, with the third counting chain, produce its own PLL loop. Gating inputs, the 4-to-1 selector for the gating inputs on the bottom two. The top one won't be gated, and just the bottom two. And they will be able to either pull from external gate input, processor controlled gate, or gated via the first counting chain, which is going to act mostly as a reference counter or divided external input counter. And each of those three counting chains have an output, direct output to the outside world after the 8254 counter before it goes into the processor counter, and those serve as functional outputs for like divided reference frequencies or a synthesized output or whatever. And the base functionalities that you could come up with this is either 3 32-bit counters, event counters, or single 64-bit frequency counter. Well, actually it'd be a 48-bit frequency counter, and a dual 32-bit frequency counter gated by the primary counting chain, or synthesized frequency output that will be either a multiple or derivative of one of the two external inputs, or phase locked to the crystal oscillators in question. So you have dual synthesized phase locked outputs, 3 possible counting outputs, or the highly configurable counting chains, however you want to lay them out. You can daisy chain it, like if I wanted to, I could daisy chain, have the first counter running off of the input, then the output of that daisy chained into the second counter, into the third counter, and then finally into the final counter in the processor, which would provide the ability to generate a 64-bit event counter, or as I said, 3 individual 32-bit counters. So that's general idea and overview of what I'm planning on doing. Some of the basic modes I'll have direct firmware implementation, and in others you would just be able to crank it over to a dual frequency counter or dual event counter or triple event counter or whatever. And then the final mode will be a manual mode where I'll be able to take and manually set which input I want to which device via the switching matrix and stuff, for situations where a situation comes up that I didn't anticipate, needing a certain functionality, so I'll be able to just on demand select which I want to run off of what other ports or outputs or inputs. So this will truly be what you could call a field programmable counter system, a field programmable timer counter and the like. Truly be field reconfigurable from the front control panel. So that's my goal. See how far I get. So take care. See you later.